Hey everyone, have you ever submitted a pull request where all the tests pass, the feature works perfectly, and yet your code review comes back with request changes in bright red? Yep, me too. And it's frustrating because you're thinking, hey, but it works. Today we're going to talk about the hidden rules of code review that nobody tells you about. Because here's the thing, working code is just the minimum bar, it's not the finish line. So let's look at cognitive load, a bad example. Your code isn't just read once, it's read hundreds of times over its lifetime. Every time someone debugs an issue, adds a feature, or tries to understand how the system works, they're reading your code. So let's look at this example. We have the variables d, y, m and dy. The code works fine. And the tests pass, but every single person who reads this has to mentally decode what each variable means, and that's what's known as cognitive load. So let's look at a better version of this. Now, looking at this version, you can see we have variables today, year, month, day, API data, process data, etc., etc. Basically, it's self-documenting. The person reading this code doesn't have to spend mental energy figuring out what's going on. They can immediately understand the intent and move on to the actual logic. So remember, good code doesn't make you feel smart for writing it. Good code makes the next person feel smart for reading it. The next big one, premature abstraction. And yep, I've been guilty of this one. You get excited about design patterns and suddenly you're building a data processor factory with a processor registry and a strategy pattern for a feature that literally runs once a day. There's a principle called YAGNI. You aren't going to need it. So here's the truth. Abstraction is powerful, but it comes with a cost. Every abstraction layer is another place where bugs can hide. Every interface is another thing future developers need to understand. So let's look at a better version. The better approach is start simple. Just write a straightforward function that does the thing. When you find yourself copying and pasting that code for the third time, then abstract it. When you have 3 real concrete use cases, then build the framework. As a rule of thumb, don't abstract until you have at least 3 examples of the pattern. 2 is coincidence, 3 is a pattern. Another bad example, missing the why. Comments should explain why, not what. The code already shows what you're doing, right? So when you write convert to milliseconds above multiplying by 1000, you're not adding value. The code is literally showing that conversation. Let's look at a better version. But when you write API times out after 5 seconds, so we use 4.5 seconds to leave a buffer, now you're explaining why this specific number matters. Or take this retry loop. Retry 3 times is obvious from the code, but third-party API occasionally fails with 503 errors. Retrying usually succeeds within 3 attempts. That's gold, right? That tells future maintainers that this retry logic exists and helps them understand if 3 is still the right number 6 months from now. Remember, context is everything. When you come back to this code in 6 months, you won't remember why you made the decisions. Help your future self out. Scope creep, my personal favourite. Let's say you opened a pull request to fix a button bug. Simple, right? But then you notice the form validation was messy, so you refactored that. And while you were there, you reorganized the components, and you also updated the styling system too. So now your simple bug fix touches 47 files. What's a better version? Better version? Well, basically here's the problem, right? Understand that every additional change makes the review harder. it makes deployment riskier, and if something breaks in production, good luck figuring out which of those 47 file changes caused it. One pull request, one purpose. Fix the button bug, ship it. Then open a separate PR for the form refactor, then open another one for the component reorganization. Smaller PRs get reviewed faster, deploy more confidently, and reverted more easily if needed. Another bad example, inconsistent style. Your code works but looks foreign in the code base because you use promises when everybody else uses async await, or use snake case when the team uses camel case. You know, I get it, right? Everybody has their preferences. I certainly have mine, but consistency beats personal preference every single time. Let's look at a better version. The goal is for the entire code base to look like one person wrote it. I'll say that again. The goal is to make sure the entire code base looks like one person has written it. When someone is reading through the code, they shouldn't be able to tell where your code starts and someone else ends. Match the existing patterns. Follow the team conventions. Use the linter. Your future teammates will thank you for it. Poor error handling. The happy path works perfectly. You tested it manually, it works great. What about the bad path? The sad path. In this example, we're updating a user. It's wonderful, but what if the user doesn't exist? What if save fails? What if the data is invalid? Let's look at a better version. Production code needs to handle failure gracefully. You need to ask yourself, what could go wrong here? And then handle those cases explicitly. Fail fast with clear error messages. Don't let invalid data propagate through your system. Don't let a null reference crash your server. The difference between junior and senior developers often comes down to how they think about error cases. Juniors think about what should happen. Seniors think about what could happen. Magic numbers. What does 50 mean? What does 300,000 mean? What does 0.75 mean? These numbers might make sense to you right now, but they're meaningless to anyone else, and they'll be meaningless to you in 3 months. Let's look at a better version of this. Use name constants, i.e. max users per page tells a story. Retry milliseconds with a comment showing it's 5 minutes, that's documentation. Success threshold makes it clear that this is a configurable business rule. When the product manager asks you to change the threshold, you want to be able to find it quickly and change it confidently. Named constants make that possible. Testing shortcuts. Tests pass, but do they actually test anything? Expect result to be truthy. This test will pass if the function returns 1, true, hello, or literally any non-falsy value. It tells you nothing about whether the code is actually working correctly. Let's look at a better example. Good tests verify specific behavior. They document what the code is supposed to do. They give you confidence that when you refactor, you haven't broken anything. Also, test the actual business logic. Check that the email is what you expect. Verify the name is set correctly. Make sure the ID is generated. Your tests are documentation for future developers. Make them count. So, let's look at the real goal of a code review. It's not really about finding bugs. Modern testing catches most of those. Code review is about knowledge sharing. It's about maintaining code quality over time. It's about catching edge cases and ensuring long-term maintainability. When a reviewer asks you to change something, they're not saying, hey, your code doesn't work. They're saying, this will be easier to maintain if we do this. Or, this matches our patterns better. Or, future you will thank us for this clarity. So, final thoughts. Before you hit that submit button on your next pull request, ask yourself, can someone understand this code in 6 months when the context is faded? Does it follow the team's conventions and patterns? Is it as simple as possible but no simpler? And does it handle errors gracefully? Like I said before, working code is the minimum bar, not the finish line. Great code is code that disappears. Code that's so clear and well structured that future developers don't even notice it. They just understand it and move on. So, thanks. Remember, you're not writing code for computers. Computers don't care if your variables are named X or user account balance. You're writing code for humans. Write code for the tired developer at 2 o'clock in the morning who's trying to fix a production bug. Write code for the new team member trying to understand how the system works. Write code for yourself in 6 months when you've forgotten everything. So that's it for now. If this helped you, give it a thumbs up and subscribe, and let me know in the comments what code review feedback frustrates you the most, and see you next time. Cheers.